So here's the thing about the unit circle that most explanations get wrong. They hand you a chart of 30 numbers and tell you to memorize it. By the end of this video, you're going to be able to find sine 210 in about 3 seconds without memorizing a single decimal. Today we're doing the unit circle, and I'm going to show you the part that everyone gets wrong. Most students do this problem completely backwards. They try to memorize sine and cosine as separate abstract numbers. There's a better way to think about it. Picture a Ferris wheel with a radius of exactly 1. As the car spins around, how far right or left are you? That's your x coordinate. How far up or down? That's your y. Keep that Ferris wheel in your head. Every single thing we do today ties back to it. Here's the intuition for any formula. At that point, move around a circle. Its horizontal position, left to right, is what we call cosine of theta. Its vertical position, up or down, it's sine of theta. That's genuinely all sine and cosine means. They're just coordinates on a circle of radius 1. I know that sounds almost too simple. Here's why it makes sense. It's the same Ferris wheel from a second ago, just with an angle attached instead of a clock position. Let's break this notation down piece by piece, so it's not just symbols, and it actually makes sense. A point on a circle at angle theta has coordinates cosine theta, sine theta. Three things that make this usable instead of memorized. The reference angle. That's the only angle you ever calculate. The quadrant sign, which tells you positive or negative. And the key triangle. Every single reference angle collapses down to just one of just two triangles. Two triangles carry the entire unit circle. Let's find the sine of 150 degrees. First, where is 150 degrees? It's in quadrant 2, between 90 and 180. Second, the reference angle. The distance between x-axis is 180 minus 50, which is 30 degrees. Third, sine of 30 is 1 half, straight from the 30, 60, 90 triangle. Last step, the sine. In quadrant 2, sine is still positive, so nothing flips. Sine of 150 degrees equals 1 half. Okay, so this is where most people mess up. Watch the step. Cosine of 7 pi over 6. First, convert to degrees, if that's easier for you. 7 pi over 6 is 210 degrees. That's quadrant 3. Reference angle is 210 minus 1e, which is 30 degrees again. Same triangle as before. Cosine of 30 is root 3 over 2, but quadrant 3. Both x and y are negative there, so cosine flips negative. Final answer, negative root 3 over 2. The triangle never changes, only the sign does. Now, three places where this always goes wrong on exams. 1. Mixing up the sine and cosine under time pressure. Tie back to the wheel. X is cosine and y is sine. Always. 2. Forgetting the sine flip. Remember, the reference angle only ever gives you a positive number. The quadrant is a separate step that decides the sign. And 3. Degrees versus radians. Check your calculator mode before you touch a single button. This one costs more points than actual math does. Now pause the video, try these three. I'll wait. Okay, let's work through these, not just the answers, the reasoning. Number 1, sine of 240. Reference angle 60 degrees, quadrant 3. So it's negative root 3 over 2. Number 2, cosine of 5 pi over 4. That's 225 degrees. Reference angle 45. Quadrant 3 again. Negative root 2 over 2. Number 3, tangent of 315. Reference angle 45. Quadrant 4, where tangent is negative, so negative 1. If you got 2 of 3, you already know this better than most of your class. Okay, so here's what I promised you at the start. There's a memory shortcut called ASTC. All students take calculus. Quadrant 1, all three are positive. Quadrant 2, only sine. Quadrant 3, only tangent. Quadrant 4, only cosine. And here's the AP specific part on free response. Graders want to see, you state them, reference angle, then the quadrant, and then the sine, as three separate steps. That's the exact sentence that gets you a partial credit even when the final number is wrong. So to recap, 1. The circle has radius 1. Coordinates are cosine theta, sine theta. 2. Every angle reduces down to a reference angle in one of two triangles. 3. The reference angle gives you the number. The quadrant gives you the sign. 4. ASTC tells you which ratio is positive where. The practice worksheet, quiz, and homework are all linked in the description below. Do the work.